Welcome to the Science of the Solar System on Coursera, offered by Caltech and taught by me. I'm Mike Brown. I'm a professor of planetary astronomy here at Caltech, and I'll be taking you on this journey over the next 9 weeks through the solar system, beyond the solar system, delving into what I hope will be fascinating aspects while learning about the science that we use to explore the solar system along the way. In this introduction, I want to answer a couple questions that you might have, such as, why are we doing this class? Should I be taking this class? What should I expect in this class? Why are we doing this class? Because I love the idea that I can reach so many more people in this class than I will ever be able to reach in my classrooms here at Caltech. I can talk to people around the world and explain to them how science works, how the solar system works, and get them excited about these things that we as scientists are doing all the time. There aren't many opportunities to do that, and I'm pretty excited about this new format and these sort of classes that are being offered online. And I think of it as an experiment. Is this going to work? I hope so. Are you going to get a lot out of it? I hope so. There is a second reason for doing this class, and that's one that most of you won't realize, but it's that this class, these lectures that you're watching, are part of my class here at Caltech. At Caltech, it's called GE 11C/103. It's taken both by sophomores as part of the geological and planetary science track, or taken by graduate students who are beginning in the geological and planetary sciences, or graduate students or students from elsewhere. And here at Caltech, they will be watching the same lectures that the rest of you will be watching online. I'm actually very excited about this part of the online class system, that these students will be able to watch the lectures before coming into class, and then we'll be able to have much more in-depth discussion in the classrooms. So I find that this class format fulfills two strong goals that I have: to be able to bring more of the science to people around the world, and to be able to better teach a class here at Caltech. The second question was, should I take this class? And I can answer that for all the different groups of people. If you're the Caltech students who are required to take this class, the answer is yes, you should take this class. If you're somebody who's taking this class purely for fun and for entertainment, and you're wondering, is it going to be over my head? Is it going to be too hard? Is it going to be too easy? Is it going to be interesting? Let me give you a little bit of a flavor of what it'll be like, and you can make that decision. The class will not be for everybody. We will talk science. We won't just show pretty pictures. We'll be talking about the science, but it's not going to be a terribly quantitative type of science for the most part. We will not be sitting around deriving Maxwell's equations and trying to understand electromagnetic interaction with subsurface regoliths. Not only that, we won't even be using most of those words that I just used. But we will be using scientific concepts and scientific explanations and scientific shorthand. If you've been away from science for a while, or if you have never really had that strong of a background in science, there will be times, I suspect, where you will be lost or uncomfortable or both. What I really hope, though, is that you persevere, you carry on. You can get most of the contents, most of the intellectual contents of this class, or at least the concepts of this class, by paying attention to the science, even if you don't understand all of the details of it. The details are there for those of you who want to get the details, and there will be ways that you can get even more of the details in this class, but you don't need to. You do not need to come to the third or fourth lecture where we're going to be talking about the polar caps on Mars, and we're going to start to do equations of heat balance and subsurface flow. We will really do those things, and I really will draw out those equations on the board. And a lot of you might at that point tune out and decide this class is not for you. I hope you don't. I hope if you get to a point in one of these lectures where you think it's just too much, you can always click ahead, see if we get back to talking about more things that you can understand. You can go to the next lecture. You can skip a few. I will not be offended. You are not required to watch every single one of these lectures and to finish every one of the assignments, because you're taking this class for fun, for your own education, and I think that's spectacular. So I want you to get as much out of it as you can, and as much out of it as you have time for, and as much out as if you want to. Caltech students who are required to take the class, ignore everything I just said, watch all the lectures carefully, do all the assignments, do the homework. So the third question is, what is this class going to be like? Well, you've already seen how it's going to start. They're going to be video lectures like this. There are something like 2 hours worth of video lectures per week, and embedded inside those video lectures are going to be places where we stop and ask questions, sort of like this. And at the end of each of those videos, you will have the chance to discuss the material there with fellow students, with the TAs, with me on the discussion boards on the Coursera page. Class is arranged into 4 major units covering 4 major topics. The first one we're going to be starting right in on is trying to understand water on Mars and the history of water on Mars. This one is such a rich topic, and there's so many interesting directions we can go on this topic that this one actually takes 3 weeks. The other units are only 2 weeks long, but because we're introducing all sorts of new things in these first 3 weeks, we're going to spend those first 3 weeks purely focusing in on Mars. At the end of each week, there will be a test. The good news and the bad news about this test is actually, it's the same news. The news is that I'm still not comfortable with the ways that we could do grading of problem sets and handwritten tests or even typed in tests on platforms such as these. I just don't think that we can do it in a fair way and give everybody the correct feedback, get the right answers. There are experiments where people are trying to do that. I don't think that problem has yet been solved. So the good news, bad news is that these unit tests are going to be short answer, going to be multiple choice. They are not going to be things where you sit around and derive equations. They're going to be more conceptual than quantitative. There will be things to calculate, undoubtedly, but for the most part, the real question will be, did you understand the material? Did you understand the point of the material? Do you understand the science of what we're trying to do? I anticipate that these tests will be accessible and passable by people who pay attention to the video lectures, who ask questions in the discussion boards, but maybe who did not have the scientific background that some of the other people had. I still think that that'll be okay. Now, the part that I wish I could invite all of you to participate in, but I still don't have a mechanism for doing that, is the in-class assignments that we're going to have here on the Caltech version of the class. So the Caltech version of the class meets twice a week for an hour and a half each time. And in class, rather than them listening to me lecture because they've already seen the videos, we'll be working on specific problems, more quantitative problems of the type that I am not able to really work on in this online format. The Caltech students will also have a short homework, quantitative homework assignment that we will grade here on campus, but that would be impossible to figure out how to get graded for the entire class. Although, as I said, I cannot figure out a way to invite you to participate in those, you can at least watch over our shoulders. We are going to have the students who are in the class here at Caltech be keeping a blog on what happens in the class lectures, looking at those quantitative problems we're working at, talking about the solutions to them. I will post the homeworks that the Caltech students are working on online for everyone to see, and I'll post the solutions once the Caltech students have turned in their solutions too. And so you have the opportunity to take this almost as if you're a Caltech student by taking place in the Coursera version of the class and then following along over our shoulders on the problem sets and on the in-classroom assignments. And I encourage, as many of you are interested, to please do that. I think it's an opportunity that I'd love to present to you, and I just wish we could do it in a more formal classroom setting that currently we can't quite do. If you don't want to do that, that's fine. You will get a lot out of this class if you're interested in the solar system and just interested a little bit in how the science of it works, even if you don't do these more quantitative problems, even if you don't follow along over the shoulders of the Caltech students. And I just want to encourage you to stick with it if you're interested. I am thrilled that each one of you is here and taking your time to learn something about the solar system. And I and the TAs here in this class are committed to making this an experience that works out well for students online, for students at Caltech, for students everywhere. Again, I want to thank you for participating. If you've listened to what I've said and you think this might be interesting, I encourage you to keep going and go click on that next lecture and start to hear about the crazy, crazy ideas that people used to have about what was on the surface of Mars.